In this review section, we're going to be looking at polynomials. So let's review some of the concepts that you should be familiar with, such as monomial, polynomial, adding and subtracting polynomials, multiplying polynomials, your known formulas for special products, which oftentimes if you haven't already memorized them, it's okay. I don't quiz you on knowing your special product rules, but we will talk about them. Dividing polynomials using long division, and working with polynomials in two variables. The multiplying polynomials, we're going to look at FOIL, completing the square, factoring by grouping. And this is usually the part that we need a little bit of review with. You are going to be working with this a lot this course, so we want to make sure you're comfortable with this topic. So let's talk about what a monomial is. A monomial is one variable, right? So one variable. It's usually raised to a non-negative integer power. A monomial is of the form axk, where a is the constant, x is the variable, and k is an integer. So again, this, just like we saw in the other videos, it'd be like this, axk. So we call a the constant, the coefficient, and k is the degree, which is the exponent of the monomial. So let's take a look at these questions here. So in question number 1, the monomial is 4x to the third. The coefficient is 4. And the degree is 3. In the second one, 5 is the coefficient, and there is no x relates x to the 0 power, so the degree is 0. In the third one here, -3 is the coefficient, and the degree is 2. In x to the 7th, 1 is the coefficient, because there's a 1 here, and the degree is 7. In question number 1, 2, 3, 4, 5, the degree is 5, and the coefficient is the negative square root of 6. So let's talk about things that are examples of what are not monomials. So you see how 4x to the 2/5, it's not a monomial because the exponent is not an integer. And you'll start to see what that means when we start to look at the graphs of the functions. But we want to make sure that the exponent is an integer. So this would not be a monomial because of this idea. 3x minus 2 is also not a monomial. Well, that's not a monomial, but what this question is asking is 3x to the -2 is not a monomial since the exponent of the variable is -2, and -2 is a non-negative integer. So it's about polynomials. So don't mind the extra little scribble I put in here. It's the exponents in sync nice. So you have a to the n, x to the n, a to the n minus 1, so that means the exponent just get reduced to degree, and x to the n minus 1, so this one got reduced to degree, plus a to the 1, x to the 1, and a to the 0. So you have this a to the n plus 1, well, you go all the way down to a to the 1, a to the 0. They're the constants. They're the coefficients. Similarly, your variables are reducing in degree each time as well. We call this a term, whichever one is present in the term itself. We call that the coefficients. The one right in the front is your leading coefficient, and it's called your leading term with the x variable. And n is the degree of the polynomial, and this is the n, that's your degree, the one that's on the x. So let's look at an example. Since this is a little scribbly, we'll look at an example that might help us. Okay, so let's take a look at these 5 examples. In the first one, you have coefficients of -6, 3, -4, and 1. Now the degree of the polynomial is the leading term degree, so right here, so the degree is 3. In the second one, your coefficients are 4, 0, and -3. You may say, well, how is there a 0? Well, notice this is 4x squared plus 0x to the 1 minus 3. Your degree is 2. Let's look here. Your coefficients are 8 and radical 3, and your degree is 1. Your coefficient here, this is 4x to the 0, right? So the coefficient is 4, and the degree is 0, and everything here is 0, or we say none, because it doesn't exist. So let's try this question now, and it has to do with adding polynomials. So when you add polynomials, you look for their like terms. So we're x-ifying the sum of 7x to the third minus x squared plus 5x minus 1 with 4x to the fourth minus 3x to the third plus 2x squared plus 2x. So let's take our terms, and we're going to do horizontal addition, which means we're going to group them. So I look for the leading and the highest terms first. So I do x to the fourth, and I don't see any of the x to the fourth plus 4, and then the 4. So now I'm going to look at the x to the thirds. I have 7x to the third minus 3x to the third. Now I'm going to look at the second powers. I have negative x squared plus 2x squared. And then I look at the 1 powers. I have 5x and 2x, and then the 1 is left behind. So now we work with each parentheses. We have the 7 minus the 3 is 4. We have the negative 1 and the 2, and that's a positive 1. And the 5 and the 2, and that's 7x minus 1. And that is your answer. As another method is vertical addition, where you line up all the variables on top of each other that are like. So let's say we have this question. We have 4x to the fourth minus 3x to the third plus 2x squared plus 2x plus 7x to the third minus x squared plus 5x minus 1. These up here are just to give you your guide of where you're going to line them up. So when you add everything through, you get 4x to the fourth plus 4x to the third plus 1x squared plus 7x minus 1. And you should get the same previous page, which we do. So what about now if we're dealing with subtracting of polynomials? So the big thing here, which most people make their mistake is they need to make sure that they distribute that minus sign and change the sign of every single term within those parentheses. So it's really 4x to the fourth minus 5x to the third plus 7x squared minus 2 minus 3x to the fourth plus 9x squared plus 5x minus 3. So you gotta be super careful. And so using the same method that we did in the previous example, you pair up the like terms. So there's no other no x to the thirds. We have 7x squared and 9x squared. We have 5x, and then we have negative 2. Oops. Negative 2 plus a negative 3. So this one will give us a 1x to the fourth. This will stay negative 5x to the third. This will give us a 16x squared, 5x minus 5. The only thing I would do is just make this a minus sign. And that's our answer. So now let's start multiplying polynomials. So you learned the idea of FOIL in the past. So basically it's just a glorified distributive property. You're going to take the 3x and you're going to distribute it to each of the 3 terms. And then you're going to take the 4 and you're going to distribute it to each of the 3 terms. So let's do it. You have 3x times x squared plus 3x times negative 2x plus 3x times 3. Now we do the 4. Plus 4 times x squared plus 4 times negative 2x plus 4 times 3. That will give us 3x to the fourth minus 6x squared plus 9x plus 4x squared minus 8x plus 12. And we look at our like terms. We have an x squared term and an x squared term. We have an x term and an x term. 3x to the fourth has nobody to pair with. It's negative 6x and positive 4x gives us a negative 2x squared. Positive 9, negative 8 is a positive 1x plus 12. And that is your answer. So in these questions now, we're going to use the topic of FOIL. So remember, FOIL means first, outer, inner, last. So we multiply the first two terms together, so we get x times x. We multiply the outer terms together, so we get a positive 2x. The inner terms together, we get a negative 2x. And the last, which is negative 2 times positive 2. So we clean this up, x squared plus 2x minus 2x minus 4. These two can combine, so you're left with x squared minus 4. And that's your answer. What if you have x plus 3 squared? Now be careful, this is not x squared plus 3 squared. Remember, the only time we can put the 2 with each of the terms inside is really if it's multiplication or division. So this is not okay, but we're going to FOIL this. First, x squared, outer, 3x, inner, 3x, last, 9. So you have x squared plus 6x plus 9. So in this question, similar, x minus 4 times x minus 4. And then you get first, which is x squared, outer, negative 4x, inner, negative 4x, and last, positive 16. Combine like terms, and you get this. So let's do this again. X times x is x squared. X times 4 is 4x. 2 times x is 2x. 2 times 4 is 8. Combine like terms, x squared plus 6x plus 8. Let's do this again. So you get 3x times 2x is 6x squared. 3x times 5, 15x. 2x times 2, 4x. 2 times 5, 10. Combine your inner, 6x squared plus 19x plus 10. You probably have learned some formulas for special products. I put these here for us to remind ourselves of them. We will be reviewing them in just a second. The most common one that you really should know is the difference of two perfect squares, because we'll go back and forth to these. Those, if you remember the rules of how to factor, you don't always have to remember this rule. So oftentimes this one, people don't always memorize it. But the difference of perfect squares is super important. So make sure you have that in your library inside your brain to remember. Okay, so if we go by answering these, this is the difference of perfect squares, right? So you're going to have the square of the first term, the square of the last term, and then put a minus sign. This is square of a binomial, and it's positive. So it's going to be the square of the first one, the square of the last one, and then in the inside, it's going to be 2 times 5x. So it's x squared plus 10x plus 25. I personally would much rather thinking of it without memorizing it. So this is x squared plus 10x plus 25, and FOIL it out. But this one you totally should remember. So the cube of a binomial is another rule. We're going to show it first using the square. So notice that you have x plus 3 to the third could be thought of as x plus 3 times x plus 3 squared. And x plus 3 squared is x squared plus 6x plus 3, and you got to times it by the 3. So we distribute it. So you're going to have x times x squared, x times 6x, x times 9, and then you have 3 times x squared, 3 times 6x, and 3 times 9. And then you combine them, you have x to the third, 6x squared, 9x, 3x squared, 18x, and 27. You combine like terms. Here's your square terms. Here's your x to the 1 terms. So you have x to the third plus 9x squared plus 27x plus 27. And this would be your answer, right? Now there's a rule that you can use to find this without going through the whole process. I personally always like to go through the whole process. I think it's a lot easier, unless I have the rules like next to me and at my disposal that I can reference, and you can do that as well. So here are your rules. If you have x plus a to the third, you're going to have x to the third plus 3ax squared plus 3a squared x plus a to the third. Notice that what happens, the x terms decrease in degree each time, and the a terms increase in degree each time, and the coefficient is 1, 3, 3, 1. Still 1, 3, 3, 1. Exponents of the x terms decrease, the a terms increase, and the signs change though in this one because of the negative. That's one way to remember it. I personally also like this if I had to do factoring, because I feel like the factoring isn't so obvious when it's in this form, but if you remember the rule, it does become obvious. So I recommend making a little like study guide on the side of all formulas and all rules to remember, and this should be there. Adding on to that list, you should also know the difference in sum of two cubes. So here's the difference, here's the difference of cubes and the sum of cubes and how it presents itself when it's factored. As I mentioned before, it's really hard to remember the factoring rules unless we have them memorized, specifically for the cubes, and this would be the way to know and have that memorized. As we get close to the end of this unit, we have to be mindful of the dividing of two integers, which will lead us to division of polynomials. So recall that when you divide, you look for, you use long division, right? So you think 12 goes into 62 how many times? You say 5. 5 times the 12 is 60. You subtract 2, bring down the 3. 12 goes into 23 1 times. 1 times 12 is 12. You subtract, you're left with 11. 11 is your remainder, so you put an 11 over 12, and the 51 is plus 11 over 12 is your answer. So the same strategy is what we're going to use when we now look at dividing polynomials. So let's say we want to now divide this polynomial. Your first step is to write your term that you're, like your big polynomial here in this portion underneath, and what you're dividing by over here. And when you do one term, the leading terms of each goes into it. So you think x squared times what will give me 5x to the fourth. So right here. So you do 5x squared times x squared, and you're going to write it underneath. So let me put it up here. And then what you're going to do is you're going to distribute this 5x squared to each term. And you're going to get 5x to the fourth plus 10x squared. And then you're going to subtract. When you subtract, you change the signs. One thing to note is that we usually tell ourselves to make sure we have the degree of each and every variable present. In this question, it doesn't matter, but notice how you're missing the x to the third term. So usually we put a 0 placeholder there. Because what happens is as you start to do this portion here, it might show up that you need the third power. In this question, we won't need it, which is why I had forgotten it, but you are going to need to do that later on. So the first term should always cancel out, and now when you add here, you're going to get a negative 11 x squared plus x. Then you do x squared times what will give you negative 11x, so you do negative 11, and then you distribute it. Negative 11x squared, and negative 11 times 2 is a negative 22. Change signs, plus, these go away. You're left with x minus 22 as your remainder, because we cannot multiply x squared by anything to give us x. And let me just correct my addition here. Negative 2 plus 22 is positive 20. So our final answer, when you look about what this result's going to be, it's going to be equal to 5x squared minus 11 plus x plus 20 all over x squared plus 2. So bear with me, my exponent did drop down here. I didn't fix it just yet, but realize that we want to check it. So you check it by multiplying the quotient times the divisor plus the remainder. So 5x squared minus 11 x squared plus 2 times the x plus 20 plus the x plus 20. So as you check it, you'll realize that you're going to get the same answer here that you started with, and just as your just means of doing a check to make sure. So quotient times divisor plus the remainder will be equal to the dividend. So here's an example of one where you need to have 0 placeholders. So when I set up my dividend, I have x to the 4th, but I have no x to the 3rd, so I have to do 0x to the 3rd. X squared, I have no x to the 1 term. And this is how you'd want to do your division. So you take x to the 4th, and you say, well, what do I have to multiply x squared by to get x to the 4th? Oh, another x squared. So you're now going to multiply that to each of the terms and then write them underneath. So x squared times x squared is x to the 4th. X squared times negative x is negative x to the 3rd. X squared times 1 is 1x squared. Now change your signs. And so this goes away. We're left with x to the 3rd. This gives you a minus 2x squared, and then bring down the 0x. Repeat the process. X squared times what will give me x to the 3rd? Well, that'll be a positive x. Repeat the process of distributing. X times x squared is x to the 3rd. X times negative x is negative x squared. X times 1 is 1x. Change your sign. So you're left here with a minus x squared minus 1x plus 1. And I see it looks sort of similar, a little different here. So we have x squared times what will give you a negative x squared. That'll be a negative 1. So negative 1 times x squared is going to squeeze it in here, negative x squared. Negative 1 times negative x is a positive x. Negative 1 times 1 is a minus 1. To change those signs. So this will become positive. I squished it in. Minus, positive, positive. So I'm left with a negative 2x plus 2. And you see that much more cleanly presented right here. Here's the result, the remainder right there.